class. Today we're going to take a look at graphing linear inequalities. And we're going to go through the steps to solve them. When we graphed just regular inequalities on a number line, we had to shade one side of the line or the other. When we're graphing on a coordinate plane over here, we're going to have to shade either somewhere over here or somewhere over here, depending on where the line is. So we'll need to figure out where our line is, and that will determine where we end up shading. Now, when we graphed on a number line earlier, we used either round brackets or square brackets or solid dots or open dots. You can't really have a round line or a square line or a open line, but you could have a solid line and you could have a dashed line. So we need to discuss what kind of lines you're first going to use, because in step 1, what you're going to do is graph the line the same way you would if there was no inequality in it and just had an equal sign. But when you do that, you're either going to make the line dashed or solid. When you use less than or greater than, these two are going to be dashed lines, because those tell you to get as close to the line as possible, but don't actually touch that line. If you have less than or equal to or greater than or equal to, these two here, because you can include the line, are going to be solid lines. So that's how you determine what kind of line to draw when you're graphing. Notice that in our first example here, this is a less than symbol. So on this one here, we're going to use a dashed line. Also notice that this line here, if the inequality was not there, would be in slope-intercept form. So we're going to graph it by starting with the y-intercept, which is at the point 0, 2, which we can tell because the b here is 2. So we're going to use the y-intercept at 0, 2, and then we're going to use the slope, which happens to be negative 2/3, to move from that 0, 2 to another point. So let's first plot 0, 2. It's right here, so we'll plot it and label it. And then we're going to use our slope of negative 2/3 to travel to another point. The negative 2 means to go down 2, and the 3 means to go forward 3. So we're going to go down 1, 2, and then forward 1, 2, 3. And we land right here at the point 3, 0. So let's go ahead and plot that point and label it. And if we want a third point, we can continue and go down 1, 2 more and forward 1, 2, 3 more, and we land here at 6, negative 2. So we're going to go ahead and plot that point at 6, negative 2. Now, because we had the less than symbol, we're going to go ahead and connect these using a dashed line or a dotted line, and that looks like this, and that signifies we'll get really close to the line, but we won't actually touch it. Now we need to determine where we shade. We're either going to shade this side of the line or this side of the line. To determine where we shade, we need to test a point. And you always want to pick an easy point. Anything with small numbers. If the line does not go through this point right here of 0, 0, that's a good point to use as your test point. So since this one doesn't go through 0, 0, let's go ahead and plot it and use it as our test point. Since 0, 0 is located on this side of the line, if we test it and it actually works in the inequality, then we shade over here, because this side is the side with all the true points. If we test it and it is false, then we will shade the other side by default, because either the side of the line is true or false. And there's only two sides and two options. So let's go ahead and test our point. We're going to test 0, 0 in our equation. So we're going to place the y and the x with 0. That makes this disappear, and we get 0 less than 2. And that is true. 0 is less than 2. And 0, 0 is located over here, so this side is all the side the side with all the true points, and the other side is the side with all the false points. So we're going to shade the side where everything is true. So that means that this side over here is the side that gets shaded. And this picture with the dashed line and the shaded side of the line is actually the graph of this particular inequality. Now let's do one more where we are going to be graphing another inequality, but it might be in a little bit different form. And we might have to treat it just slightly different. So we're going to make a coordinate plane because we know we're going to have to graph it. And we'll go ahead and label a few things to get our scale down on the graph. And let's say that we're asked to graph the inequality 4x plus 5y greater than or equal to 20. Now, first thing that I notice on this is that I have greater than or equal to. So when I graph my line, I'm going to use a solid line because we can include the line. Now I also notice that this equation here happens to be in standard form. Since it's in standard form, when I graph it, I'm going to use the x and y intercepts to graph it. So I'm going to make a little table here that I'm going to fill in with my x and y intercepts. So I'm going to have x and y in the first two columns and then the ordered pair x, y in the last columns. And I'm going to find the y-intercept first by letting x be 0. And then I'm going to find the x-intercept by letting the y be 0. And then we'll plot those and connect them with our solid line. So first by letting x be 0, and when you're finding these points, ignore the inequality and just use an equal sign. So we have 4 times 0 plus 5y equals 20. These cancel. And I can go ahead and just divide by 5, and y is 4. So that gives me the ordered pair 0, 4 for my y-intercept. Now, if I go ahead and plug in 0 for my y, I get 4x plus 5 times 0 equals 20. This cancels. Divide both sides by 4, and I get that x equals 5. So that gives me an x-intercept of 5, 0. Now let's go ahead and plot those points. I have 0, 4 located right here, and I have the point 5, 0 located right here. And according to my inequality here, I need to connect those with a solid line. Now I need to determine where to shade this particular coordinate plane. I'm either going to shade on this side or that side of the line. So I'm going to test a point, and the easiest point to test is the origin, and it does not go through the origin. So let's locate the origin and test it out to see if it works in our inequality. So I'm going to test 0, 0, plugging 0 in for my x and 0 in for my y. I want to see if it works out. And that gives me 0 greater than or equal to 20. Well, that's not true. 0 is not bigger than 20. So this is a false statement. Since my point 0, 0 is located on this side of the line, and it did not work, that means everything on this side of the line will be false when it's plugged into that equation. By default, the other side of the line is where all the points are true. So we want to shade the other side of the line because that's where all the points satisfy that inequality. And that is how you go about graphing inequalities.